All right, students, remember to hit pause so you can write down any of the notes. Today we are working on comparing percents, fractions, and decimals. How do I convert between percents and decimals? So if I have a percent, how do I make it a decimal? And if I have a decimal, how do I make it a percent? Remember from section 5.1 that the word percent means part of 100. Cent is always standing for 100. Per is part, so part of 100. Going from percent to decimal. When you're looking at a percent, think about what the best percent that you could earn on a test would be, and that's a 100%. Now, obviously, you could have some extra credit, but let's just talk about overall. You're looking for that 100% on your test. So here I have a 35% on my test, and I want to turn that into the decimal. I already have the percent, and I want to turn it into the decimal. Well, this would be 35 out of 100. 35% meant 35, and the percent part was part of 100, so 35 out of 100. Now, what does this line here mean? Well, this line here means to divide. I'm only going to show you this long way one time, and hopefully after that you'll notice the shortcut and understand. But I don't want to start with the shortcut until you know what's happening. So really this means take 35, divide it by 100, and that's what we have here. So to take 35 and divide it by 100, I can't do that because I do not have enough parts in order to put 100 into it. So I need to add a 0. Well, okay, you guys are going to catch me for that. Not add a 0, but I'm going to place a 0 at the end after a decimal to increase my place value spots that I'm holding now, because 100 did not go into 35, did not go into 3, and did not go into 35. Does 100 go into 350? Yes, it does, 3 times. 3 times 100 would give me 300. And if I subtract these, I get a 50. Again, I'm going to put another 0 here to hold my place value, and I drop it down to the bottom. Does 100 go into 500? It does. And it'd be an even amount of times, and so this would be my final answer, the 0.35. If you were in class and you're just coming back for a refresher, you would notice then what had happened is that this 100 told me to move the decimal place 2 times, once, twice, because it was the hundredths, so I'm moving it 2 place values back, and that's how I got this. Another thing you can do to check is to actually say this word. I know us teachers and a lot of people say 0.35, but really it's 35 hundredths, which is the same as this, 35 over 100, 35 hundredths. And then this would be our answer. We wrote it as a decimal. We're done. It started as a percent, and now it's a decimal. Let's try another example. So 27%. So I'm going to take 27 and place it over 100. We know from the last example that if I was to come and take 27 and divide it by 100, and again I'm not going to do this whole thing, but we would have to hold our place value, and we would find out our answer would be 0.27 or 27 hundredths, because it's the same thing that happens over and over again. It's like taking the shortcut and moving the decimal to the left twice. Because I'm dividing it by 100, this number is going to get smaller. I move it twice because of the 2 zeros, and it's that many place values. We're going 10 hundredths to the hundredths place value. All right, 145%. Well, 145 over 100. So something weird's going to happen here. If I just go and use my shortcut and go once, twice, well, I'm going to get 1 and 45 hundredths, 1.45. And so then you start thinking to yourself, well, okay, all of them were supposed to be part of 100, and they have been smaller, and now all of a sudden this is bigger, and well, why is that working out? We'll go back to your original percent. 145%. This is already bigger than 100. What it means is I have 100% plus 45%. 100% plus 45% would be like 100 over 100 plus 45 over 100. Well, what's 100 over 100? 1 whole. What's 45 over 100? Well, if we were to apply the same principles that we did for the first 2 examples and move the decimal back twice, we would get 0.45. Add them together, 1 plus 0.45 or 45 hundredths, I get that answer. So the shortcut still works in this case. Ooh, so we got another tricky one here. We just dealt with a tricky one up on top, and now we got another tricky one with the decimal already being here. So I want you to think about what's going on in this problem. 2/10 of a percent. 2/10 of a percent. So think about having 1%. You have even less than that here. This is 2/10 of a percent. This is even less than 1%. It's pretty small. So let's figure out what that is as a decimal. Well, in all of the other problems, all we've done is taken the decimal, notice it's right here, and moved it twice. Once, twice. When I have this extra place here, I'm going to hold its place value with a 0. So I'll get 0.002. That would be my decimal. Now I know some of your brains are like, oh wait, that's a super small number, Miss Bednar. And yeah, it is. But let's see what happens if I was to set this up like this. It would be 0.2 over 100. So it would be 0.2 divided by 100. The decimal point is already here, so I'm not going to put an additional 1 there. It's already here. Does 100 go into 0? No. Does 100 go into 2? No. Put a 0 here for the place value. Does 100 go into 20? No. Put another place value here. Does 100 go into 200? Yes, it does, 2 times. Lo and behold, same answer that's here. So if you ever don't trust yourself, go back and try the actual division and just make sure it makes sense. All right. So now we're going to go backwards. Here it is. New question. How do I convert between decimals and percents? So now I'm going to give you a decimal, and we want to make it a percent. So how do I convert it? First thing we have to do is think about it. How do I say that number the right way? I say this number as 2/10. 2/10. Right here, 2/10. How would I write that then? 2/10. Remember what we did in section 1? To make it a percent, we want it to be part of 100. So what is x? What percent over 100 is 2/10? This one's a nice problem because I can see that 10 goes into 100 by multiplying by 10. 2 times 10 is 20, so I know that this would be 20%. So 0.2 is the same as 20%. Let's try this next one. 1.66. 1 and 66 hundredths. 1 and 66 100ths. All right, well, I'm trying to go to a percent. And so what does this big number 1 tell me? Well, it tells me that it's already 100%. And what does this 66 over 100 tells me? Well, it's my part of 100. 66 parts over 100 tells me it's already 66%. So I have this whole percent, 100%, plus this percent, 66. So my final answer would be 166%. So some of you right now are thinking, hey, Miss Bednar, I see a pattern. The last one, you had us move the decimal back twice when we had the percent and we had to turn it into a decimal. But on these two problems, if I would have just gone once, twice this way and filled it in, I would have gotten the 20% that's right here. And if I would have gone once, twice, I would have gotten the 166 that's right here. Yeah, you're absolutely correct. That is the shortcut. I want to show you why, the reason behind it. We have to know the theory behind why a shortcut works to truly understand it. And I suppose that's not so much theory, that's just work. But I wanted you to see that. So, same thing. How do I take this decimal and turn it into a percent? Well, this would be 83 hundredths. 83 over 100 equals 83%. This one would be 1 and 764 thousandths. 1 and 764 thousandths. Okay, we've suddenly run into a problem here. And the problem is that it's not over 100. So I know that this stands for 100%. That's pretty easy. What am I going to do with this? Well, I have two options. One, if you're pretty smart with your math, you know if you divide this by 10, you'll get 100. So I have to divide this by 10 also, and I get 76.4. But let's just say that that didn't work for you. You can always set up your proportion like so. Now from this way, you might see what I was talking about. To go from here to here, I divide by 10, and from here to here, I divide by 10. So I have 764 divided by 10, which is 76.4. So now I have 100 plus 76.4, excuse me, percent, and that's 176.4%. Does that make sense? Yeah, it's okay to have a percent that's bigger than 100. So, in summary, or our summary would be to turn a percent into a decimal. I would, number one, divide by 100, or move the decimal, two places to the left. So we had one, to turn a percent into a decimal. I would divide by 100 or move the decimal two places to the left. The other one, to turn a decimal into a percent, I would either A, say the number, write the fraction, and solve if needed. And when I say solve, I mean the proportion, setting it equal to 100. Or the shortcut would be to move the decimal point two places to the right. And just we have a minute or a few minutes here for one last example. Let's say we took a test, and on the test you earned an 18 out of 20, and you wanted to know what your percent was. You could do two things. The first thing you could do is take a calculator, or do it mentally in your head, because there's a quick way to do this mentally in your head. But take a calculator, take 18 divided by 20, and you'll get 0.9. And you're like, okay, so what percent is that? So this equals 0.9. Well, I'm going to move it two places to the right. Once, twice, and I would get 90%. So that would be your quick way of solving those. All right, good luck with section 5.2.